Alright, so here we go. When I evaluate this, 0 cubed over 3 minus negative 2 cubed over 3 plus 1 cubed over 3 plus 1 squared over 2. You don't realize if I plug in 0 to both of those, I do get out 0. I could have just put a 0 here as well, but I didn't. Negative 2 cubed is negative 8, but there's negative in front of that, that makes us 8, plus 1/3 plus 1/2. That makes it 3 plus 1/2, which is 7/2. That was 26.
Oh.
28. Said let u equal the square root of 2x. Then tell me what this is. Tell me what this is equivalent to. Well, here's the deal, ladies and gentlemen. I can actually eliminate 2 of these.
Yeah.
I can actually eliminate 2 of these. Why do I eliminate 2? Oh, so Emma said I need to plug in u of 2, which is the square root of 2 times 2, which is 2, and u of 8, which is the square root of 2 times 8, which is 4. That eliminates 2 of the answers. That's really nice. I didn't do a whole lot of math. I just recognized that I need to change my limits, so 2 of my 4 answers are now eliminated. Makes it easier if I'm not totally sure of what I'm doing. Alright, so the next thing is now I need to talk about u. I said let u equal the square root of 2x. So if I'm talking about putting it in here and I'm going from 2 to 4, and it's this, that means that u, the bottom is u plus 1. Is the top just du? What do you have to do?
You have to find du.
Oh. Have I found du yet? Well, let's find du. Du, by the way, is the derivative of this, which is 1/2 times 2x to the negative 1/2 times 2. By the way, times dx, which is du equals 1 over 2 square root of 2x dx. But the problem is, do I have 1 over the square root of 2x dx on my original? I do not. I just have 1 up there. dx. So I'm going to actually get. Well, I have a question for you. Square root of 2x is what again?
U.
Square root of 2x is u. Oh. So I can write this as 1 over u dx equals du. Not divided by u. Now wait, that means there it is. I want to go back to 19. I missed those. Number 19. Says the derivative of 4 integration of 4 to x squared of t over 1 minus the square root of t. I have a question. Do you have to integrate this? You actually have to integrate this. No, because what am I looking for?
The derivative of the antiderivative.
The derivative of the antiderivative, the derivative of the integration, which really means you do what? What do what? Plug it in the function. Okay, plug what in the function? Do I plug in 4? I plug in x squared, so that's 1 over 1 minus the square root of x squared. Is that it? What else do you have to do? What's the derivative of x squared? I have a question. Do you know what the square root of x squared is?
X.
Hey, there's my answer. Because remember, derivative and integrations, they cancel each other out. It's fundamental theorem of calculus part 1. 24! Let me tell you, u of x equals integration from 1 to x of t dt. We're talking about g of -4, g of 1, g of -2, g of 5. I'll put it in order so we start. Let's talk about these. First thing I do is I recognize that these are the ones I'm talking about, yeah? And now, I'm going to plug them in. So g of x equals the integration from 1 to x. So g of -4 is going to equal the integration from 1 to -4 of f of t dt. Well, I don't know about you, but I do like my integrations to go in the proper order. So, I am going to move this. I'm going to flip it so I go in the proper order, especially when I'm talking about a graph. From 1 to -4 is this and this. An area. And two area. Can you find me the two area? Take one at a time. I have negative parentheses is going to be 1/2, 2, 2, plus 1/2, 3, -1. That's 2 minus 3/2. By the way, why is it negative?
Because when you flip it, you get to put the negative.
Yes, that negative. Why is this one negative? Because it's underneath the x-axis. And then, so 2 minus 3/2 is 1/2, but it's negative, so there's my negative 1/2. So g of 4, -4, is negative 1/2. So let's talk about g of -2. That would be this piece. That's just that piece. By the way, that would go from 1 to -2 of f of t dt. Or in our case, I like to go in order, -2 to 1. I know that piece, that's negative. I have that piece right here. That's negative, -3/2. Makes this 3/2. So g of -2 is 3/2. What's the next one I have to do?
G of 1.
G of 1. G of 1. G of 1! Which would be from 1 to 1 of f of t dt. That was really easy. You're not going anywhere. Last one is g of 5. That's going from 1 to 5 of f of t dt. That's this piece right here. So that would be 1/2 times 4 times 1, which is 2. There's 2. They're actually in order right there. No, they're not. No, they're not. So you go -4 to 1 to -2 to 5. But they need to be in order. 33. Ah, left, right, rebound sums. Here's the deal for this one. Just an FYI for 33. You had to recognize that if you are increasing and concave up, you look like this. That's what you had to recognize for 33. If you are increasing and concave up, you're looking like this. So if you think about left when you're looking like this, means you're starting at the left. My rebound sums are going to look something like, yeah, these are under. What's right going to be?
Overestimate.
What's trap going to be?
Slightly overestimate.
So by the way, when you go to do your trapezoid from here to here, that's over. That's why. I don't think it's here. That's going to be over. Slightly over, but it's over. And what do you have at midpoint? Oh, I'm sorry, then the other A is the actual, right?
Right.
Which means left is here, right is here, actual is here, and T is there. And the last one, which is 32, number 3. FYI, just a reminder, when I give you the next workbook assignment, please don't write all your work up here. It's literally spaced out for you, so you have a big space for A, and a big space for B, and a big space for C, and a big space for D. Because I had several people that tried to cram all of their work up here. And next time I won't grade it up there, because it's not in the appropriate place. Because the AP exam doesn't grade things that aren't in the appropriate place. So, just an FYI. I tell you, x of t equals 7t minus 4t squared plus the integration from 0 to t of s squared ds. And I'm asking you, for part A, it says position and velocity at t equals 3. How do you find position and velocity at t equals 3? Well, position. How do you find a position at t equals 3?
Plug 3 in there.
Plug in 3. Yep. X of 3, 7 times 3, minus 4 times 3 squared, plus the integration of 0 to 3 of s squared ds. 21 minus 36 plus s cubed over 3, evaluated from 0 to 3. So that's this. Negative 15 plus 3 cubed over 3 minus 0 cubed over 3. Or negative 15 plus 9, negative 6. There's my position. Velocity. Well, before you do velocity, what do you have to do?
Find the derivative of the position function.
Let's find the derivative of the position function. V of t. Derivative of 7t is 7. Derivative of the next piece is negative 8t. Derivative of this piece is the derivative of the integration. By the way, it's fundamental theorem of calculus. That's what that piece is, fundamental theorem of calculus. So when you do this, I've performed these already. 7 minus 8t plus t squared times the derivative of t. What's the derivative of t? 1. So v of t 7 minus 18 plus t squared. So v of 3 is 7 minus 8 times 3 plus 3 squared. 7 minus 24 plus 9. 16 minus 24 is negative 8. There's my velocity. Part B said, what's the speed? How do you find speed at t equals 3?
Absolute value of velocity.
My speed is 8. FYI, if you screwed up part A and you got negative 10 for your velocity, and you put your speed at 10, because you have the value of your velocity, you would lose the point for the velocity, you would keep the point for speed. Because you evaluated your velocity correctly with speed. Does that make sense? It's called reading through with your mistakes. The next one is it speeding up or slowing down? How do I figure out if speed is speeding up or slowing down?
Find the velocity and the acceleration.
Fabulous. I got velocity. I just need acceleration. A of t, negative 8 plus 2t. A of 3, negative 8 plus 2 times 3, which is negative 2. So, A of 3 is negative 2, V of 3 is negative 8. Speeding up, slowing down?
Speeding up.
Speeding up.
Why?
Because
that's the same size.
By the way, it means it's speeding up in the negative direction. It's speeding up. There's my justify. There's my reasoning. Because A of 3 and B of 3 have the exact same sign. Part C. In the interval from 0 to 4, the particle changes direction once. How do you figure out where a particle changes direction, Cassie? Can I what? That? Yep. Yep, because it's velocity, not the speed. When you're talking about is the velocity increasing or decreasing, you've got to use the original velocity function and the original acceleration function. So I'm literally using A of 3 and V of 3, not the absolute value of V of 3. That's why. How do you figure out where something is changing directions?
find
Velocity and then find zeros.
So V of t equals 0. So V of t is 7 minus 8t plus t squared. Personally, I'm going to write it so it goes in the order that I like it to go in. Oh wait, this is a factor. What do I do next? Time chart. This would be negative, which makes this positive, negative, positive, which makes this negative, positive, positive makes this positive. Let's see what happens. Hey, change the signs on both of them, so they're both answers, yes?
No.
Why not?
Intervals from 0 to 4.
Because of your interval. The interval only went from 0 to 4, so the only answer that I wanted. The last piece says we're farthest to the right and farthest to the left. Now I don't want Nick or Merlot to answer this. You're going to tell me why. Where would it? What's another way for me to say farthest to the right? Ooh, what? Ooh, maximum. Okay, what kind of maximum? Bridget just gave me the absolute
I'm
maximum.
doing all this right now.
Farthest to the right is the absolute maximum, so if you weren't sure about that, you want to write that down. Farthest to the right is going to be absolute maximum, therefore farthest to the left would be the absolute minimum. Now, but what John said something about, what did you say, John? Endpoints. Can we talk about endpoints when we're talking about absolutes?
Yeah.
Yes. So the values that I need to check for D would be t equals 1, 7, and what are my endpoints?
0 and 4.
0 and 4. All those are the values that I need to check. Yes. Do I need to check all these values? No, what am I not checking? Why? It's not the interval. Keep out that one, I don't want to worry about. Only check the 1, 0, and 4. And I literally need to know what their values are. I have what x is. I have the original function. So I'm literally plugging this into the original function. So that'll tell me the values. 7 times 1 minus 4 times 1 squared plus the integration of 0 to 1 of s squared ds. One minus 4 plus x cubed over 3 evaluated from 0 to 1, which makes it 3 plus 1/3, which makes it 3 1/3. Everyone okay with that? By the way, that's 10/3. X of 0 would be 7 times 0 minus 4 times 0 squared plus the integration of 0 to 0 of s squared ds. Again, what's the integration from 0 to 0? 0. Yes, ma'am. How do I know that it's in the same interval? Because if you look at the original problem is only defined between 0 and 4. That's why. That's why I'm throwing out 7, because the original problem doesn't even go up to 7. This gives you 0 minus 0, and if you reverse 0 to 0, or any number to any number itself, it's still 0, that area that exists. And x of 4. 7 times 4 minus 4 times 4 squared plus the integration of 0 to 4 s squared ds. 28 minus 64 plus s cubed over 3 evaluated from 0 to 4. 28 minus 64, let's see if I can do my math correct, is 36, negative 36.
Yeah.
Plus 4 cubed over 3 minus 0, which makes it negative 36 plus 4 cubed is 64 over 3. I have a question for you. Is that number going to be bigger or smaller than 0 and 10/3? Smaller, right? Because negative 36 is bigger than 64 over 3. So, at t equals 4 is my absolute min, and at t equals 1 is my absolute max. My reasonings are the work right there.
So you don't have to state like it's far.
I would say because x of 4 is the largest value and the smallest value. And the work shows it up there, and because x of 1 has the largest value. And again, your work shown will show that. Alright, today we're talking about the last section for this unit. You are going to need your calculators out today. You are going to need out a sheet of paper. The sideways paper are our notes for today. The other paper is your homework. You do not have bookwork, you do have this worksheet. FYI. Hold on 1 second.